you okay? Do you need to go to the nurse? All right, Zacchaeus, you keep thinking. Blaze, what do you think?
If the exponent is to the first power.
If all the variables are to the first power. No variables in the denominator, of course, that's a given, and no variables in the exponent to be linear. So to be linear, all variables to first power. That's our biggie. We have these listed over here on the board for a long time, all variables to the first power. I'm also going to put there no variables in exponent. So that's linear. How do I know if something's quadratic? The highest exponent is what? 2. It's quadratic if the highest exponent is 2. And then the one that should be most recent in your mind, how do I know if something's exponential? Variable in the exponent. Now, Aaron over here, called you default, you couldn't remember for a second. Aaron asked, could we use Desmos? If you're asked if it's quadratic, linear, exponential, and you forget, you can type it in Desmos and see what shape it makes. If it makes a line, what is it? Linear. If it makes a parabola, what is it? Quadratic. If it makes that little swoop up on one side, what is it? Exponential. But we should be able to look. So when I look at number 11, it has a variable in the exponent. Which one is that? Exponential. You could have just put E. And it's because there's a variable in the exponent. When I look at number 13, all the variables are to the first power. So what is that? Linear. When I look at number 15, what is it? All the variables are to the first power. It's in slope-intercept form. Y equals mx plus b. That's linear. 17, variable in the exponent. What is that? Exponential. 19, highest power is 2. 21, variables in the exponent. And 23, highest power is 2. Quadratic. So when you get to the EOC, you should be able to quickly look and be like, okay, this is linear, this is exponential, this is quadratic, before you do anything else. Now, will they be asking you just the simple question, is the following equation linear? I don't know. They don't let me see the test. What I do know is you'll get an equation, they'll ask you to do something, and you need to know when you look at that equation, is it a straight line, is it a parabola, or is it that swoop for exponential? And that will help you base the rest of what you do. Because if I ask you to graph something, if I ask you to compare it, you need to know what shape it makes before you start any of that. So that little quick review there, do you kind of remember a little bit of what the equations look like for each type? Yes, no, thumbs up, thumbs down, something? Okay, now, here's where the directions really would have changed. Turn back to page 6, because the directions don't say what I told you to do. The directions say, identify the following as increasing linear, decreasing linear, positive quadratic, negative quadratic, exponential growth, or exponential decay. All I asked you to tell me was it linear, exponential, or quadratic. So let's talk about, well, what is increasing linear? What would you think an increasing linear would look like? A graph with a positive slope. It's going up from left to right. So let's look at one of the linear ones. Let's look at number 13. Does number 13 have a positive slope or a negative slope? How do you know? Because where m is supposed to be, there's a -2. So we would say this is decreasing linear. So if you could put above that DEC, so we'll know it is decreasing. The only thing you should have up on your Chromebook is My Google Meet or Desmos. So if you're playing on your Chromebook and you're not even in My Google Meet, that's a hint to me you're doing something you're not supposed to be doing. Then they ask for positive quadratic. What do you think positive quadratic looks like? Let's look at this one. Would this be a positive quadratic or a negative quadratic? Negative. Why? Because it's pointing down. It has a maximum. So let's look at number 19. Well, let's look at 23. That's the easier one. When I look at 23, do you think that's a positive quadratic or a negative quadratic? A negative quadratic, because A is what we go by to tell that. This would be pointing down. It would have a maximum. When I look at number 19, we would actually have to distribute this out, x plus 2 times x plus 2, to see what it looks like. But there's a 1 in front of that x there, so we know that this would be a positive quadratic. And then the last one goes back to what our quiz trade was yesterday. So it says, is it an exponential growth or exponential decay? So let's look at the first one. When I look at this number that's inside parentheses, is that bigger than 1 or smaller than 1? 5 halves? Bigger, because 5 halves is 2.5. So that would be an exponential growth. What would make it a decay?
If the number was below 1.
If the number was below 1. So when I look at number 17, what is that? A decay, which means it's going down. So 2 things I want you to get out of the warm-up today, which is actually part of today's lesson. How do I know what an equation is? Linear, quadratic, or exponential? And then once I know what it is, how do I know if it's positive, negative, increasing, decreasing, growth, or decay? Nothing I've just shared with you is new. It's just remembering it from earlier this year. Okay? So do you see the importance of when I'm reviewing that we need to make sure we're listening to that? Because we forget things very easily. I myself. Mr. Plaza shows us something in a meeting. I don't use it for 2 weeks. I come back, he tells me to pull it up, and I can't even remember how to get to it because I haven't been using it. So we've got to make sure we're practicing. But the good news is you always have your friend, Desmos. So if all else fails, just type it in Desmos and see what it looks like and see if something comes to your mind. Okay? So now turn back to page 6. Now we're looking at graphs. When I see these graphs, I've got to tell those same little things. So when I look at number 1, what shape is that? A parabola. And which type of equation is a parabola? A quadratic. So number 1 is a quadratic. And is it a positive quadratic or a negative quadratic? Negative, because it's pointing down. So what I want you to do is I want you to try 2 through 6. I want you to see, do you think it's quadratic, linear, exponential? And then after you decide that, see if you can figure out, is it positive, negative, increasing, decreasing, those things. So try 2 through 6 real quick. You don't have to write the whole word. All right, one of you 4 over there down on that strip closest to the wall. One of you 4. Number 2, do you think it's linear, quadratic, or exponential? Exponential. Very good. And if you had to guess, would you say growth or decay? Growth. Very, very good. Number 3, somebody from the second section right here. Linear, quadratic, or exponential? Linear. And is it increasing or decreasing? Increasing, which means it has a positive slope. All right, somebody from this section right here, linear, quadratic, or exponential for number 4? Exponential, very good. Do you think it's a growth or a decay? A decay, because it's going down. Tell me a situation in life that is a decay, an exponential decay.
Stock market.
Stock market can be exponential decay. It could also be decreasing linear. It's according on how it's dropping. What else?
Yes.
The population of a species, like if the prey is running out, gas prices could be linear or they could be exponential according to how fast they're increasing or decreasing. Right now they're increasing very quickly, which makes it seem more like exponential. But that goes to show you supply and demand. When you have a small supply of something but a high demand for it, it starts costing a lot more money. Okay? Same thing is going on with vehicles right now in America. Because we had a shutdown during the quarantine where they started making ventilators at those companies instead of making vehicles, and people had to stay home during that time, we have a shortage of new vehicles here in the United States, which means people need them. We don't have them, so they're willing and have to pay more for them when they do get them. So some people can actually sell a used vehicle right now for almost the same amount or more than what they originally paid for it because there's such a demand. So that's an economics lesson for you, supply and demand. All right, and then somebody from this section right here, number 5, linear quadrant. Increasing linear. Very good. And then everybody on number 6, what is it? Positive quadratic. Very, very good. Now, 7 through 10 is more complicated, so we're going to pause before that. But what I want you to do, I'm going to present you with a topic. I'm going to tell you someone, and I'm going to give you about 1 minute for the two of you to discuss it to see what you think. It doesn't mean that you have to definitely come up with the right answer. You're just going to do talking points on each side to see what you can come up with. So if I am comparing linear, quadratic, you don't have to write this, and exponential, I'm just putting it up here. I want you to talk about in order which one you think grows the fastest, then the next fastest, and the next. So from fastest to slowest as far as they're growing. How do they grow? So if I was looking at them as all positive, all increasing, or all growth, which one would grow the fastest, which one would be in the middle, and which one would grow the slowest? So take a moment. David, if you could talk with Carson there, you two, and then everybody else, I think, has a partner near them. So just discuss, which one do you think grows the fastest, the medium, and the slowest? Go. All right, let's look at the class. Raise your hand. I'm not going to call you out for right or wrong. Raise your hand if you and your partner thought linear was the fastest. All right, raise your hand if you and your partner thought quadratic was the fastest. And raise your hand if you and your partner thought exponential was the fastest. All right, so let's look. I have put 3 examples in Desmos that we're going to look up here. We're only going to look at what's going on in the first quadrant because it's kind of hard to compare the rest. So I think that I'm just going to drag this over so we can see just this first quadrant here because we want to compare them. I'm also going to zoom in just a hair so you can see it a little bit better. So the linear one is red, the quadratic one is blue, and the exponential one is green. At different places, different ones are higher. So let's look at the first part from 0 to 1. Which one is going the fastest there, or is the highest from 0 to 1? The exponential is above right there. Then the next one is linear, and the lowest one during that part is quadratic, from 0 to 1, right? But is that very long? No. After that, they kind of start switching a little bit. So let's look at the next piece. So that would be right here after 1. After 1, the quadratic gets faster, and then the linear, followed by the exponential. But after a very short time, once we get to 2, the exponential has surpassed linear. Let's look what happens after that. After that, we're looking here. We've got this green one here is still the, who's getting left behind here? The linear, the red one. And then the green one is still behind the blue. I'm going to zoom out. They're almost getting parallel to each other. But then as we get a little bit farther, they're getting closer and closer. And what happens? The green starts surpassing the blue. And from there on out, the green is always going to be higher than the blue. So in the long run, which one is the highest with the color always? The green one, the exponential. So for a short time together, I want you to know at the very beginning, it switches back and forth. Think of it like this. And again, I'm talking broad scenario, not every individual case. Okay? Think back to elementary school. In elementary school, you start off in kindergarten, and you all kind of are the same height. Not exactly, but close. Then you start getting middle of elementary school, getting to later elementary school, and what happens to the girls? They start getting taller. The boys, not so much. Then you get to middle school. By the time you get to 8th grade, what starts happening with the boys? They start getting taller. And then in the long run, again, I'm talking overall, not every individual. In the long run, you get to high school. Who's getting taller? Boys. Girls are pretty much done growing at that point. Then by the time you get to college, for the most part, the majority of boys are taller than the majority of girls. Are there tall girls out there? Absolutely. Are there short boys out there? Absolutely. I'm not saying grand case. Cody, you still got a long time to grow. Don't you let them stretch you out. Now, Luke, on the other hand, he doesn't stand much of a chance. My Luke, not Luke that's in here. So what I want to show you there is that's kind of how it's going on here. To begin with, are you listening? To begin with, exponential doesn't look so grand. It looks like it's lagging behind, kind of like the tortoise and the hare, okay? But then exponential really takes off, and it leaves everybody else in the dust. Eventually, when you get just a hair farther, remember we did that problem yesterday, and we put in like 6 in for T, and it was already in the millions, only at the 6th term? Where we're looking at here, if we went back to the x-axis, we are, like here's negative 50. So that means this is at 50. So this would be 40, 30, 20. This is only at about 10. At about 10, it's already taken off and leaving everybody else in the dust. By the time you get to 100, exponential is so far up there, you really don't even see comparison to quadratic or linear anymore. See how low linear is compared to this, even at 10? So what I want you to see out of that, when it comes to growth, linear grows a lot slower. It's steady, though. Linear is steady. It's adding the same thing over and over and over, but it's growing slower. Exponential is like, whoop, and it takes off. Yes?
When you said the fourth order from the largest, I thought you meant...
I didn't say largest. I said grows the fastest.
Grows, yeah, well, it grows the fastest out of all of them.
You're putting the same number in for X every one of them. It's the Y that we're talking about. Because X, like you're putting in 1 for X for all 3 of them. You're putting in 2 for X for all 3 of them. 4 for X for all 3 of them. Because X is your input. It's independent. You can put in whatever you want for it. Y is what the output is that depends on the other one. Does that make sense? Okay. All right. So we are going to look at tables, which is where it gets a little bit weird. But the wonkiest part is where it gets to words. And we're going to look at that. But I want to stop the video. And I want us to look back at our quiz trade from yesterday.